Hello and welcome everybody. My name is Christian Hernandez-Blick, Head of Program at Interspecies Internet. It's my pleasure to welcome all of you on behalf of the trustees and the organization to another Interspecies Conversations event. Interspecies Conversations is a monthly online lecture series where leading thinkers share ideas and research that deepens our understanding of communication and cognition in other species. We aim to platform emerging discoveries and host open discussions where the community can join the conversation with questions and feedback. If you enjoy these events, please consider donating to Interspecies Internet to help support our programming and other projects and activities. You can find a link to our donation page on our website, that's interspecies.io, as well as in the video descriptions on our YouTube channel. And I think in the chat, Carol will share a link with you shortly as well. So today, instead of our usual lecture format, this session will take the form of a roundtable exploring an innovative approach to wildlife data collection, analysis, and interaction. Independent groups working separately with siloed species-specific tool development. The speakers joining us today are exploring collaborative development of open source modular technology for multi-species data logging, analysis, and interaction. Their efforts focus on a modular integrated architecture for collecting and logging sensor data, including audio, movement, environment, and environmental variables that can be adapted to different species, such as wolves, chimpanzees, dogs, prairie dogs, elephants, whales, and dolphins across different environments, such as land and aquatic. These tools would not only support the needs of field biologists gathering and analyzing data, but also aim to enable active interaction and help monitor wildlife behavior, detect poaching, mitigate human-wildlife livestock conflict, and inform conservation decision-making. So today we'll hear from Eric Pan, founder and CEO of Seed Studio, a leading open hardware company that provides reference designs and supply chain services for millions of global developers. Jeff Reed, a computational linguist and naturalist researching animal communication using AI-powered tools forged deep in the mountains of Montana. Patrick Chwalek, a PhD candidate in the MIT Media Lab, who specializes in designing and deploying novel multi-modal sensing systems to generate new insights into animal and human life. Joris Komen, a PhD candidate in the design and computation group at MIT and founder of Humane Labs, a design research practice exploring the intersection of technology, ecology, and the built environment. Leo Trottier, a cognitive scientist and entrepreneur who started Fluent Pet as a PhD candidate at UC San Diego. And of course, our moderator, Interspecies Internet co-founder and trustee and director of MIT's Center for Bits and Atoms, Neil Gershenfeld, who will also be presenting some work from Kat Hobader, a field primatologist, reader in Origins of Mind at the University of St. Andrews, and PI of the Wild Minds Lab, who is unable to join us in person. Okay, so with that, I'm going to hand things over to Neil.
Okay, thank you, Christian, for that comprehensive introduction. So for background, Vince Cerf and I describe our role in this program as plumbing, or plumbers. And that's what today is about. This is really not a lecture, but a working session. So a while back, we ran a workshop at Santa Fe Institute leading up to how you evaluate progress for interspecies communication that led to the Animals in Translation publication. And at that gathering, I was struck how every team and looking at every species kept repeatedly reinventing the same solutions about how you store video, audio, metadata, and create platforms to navigate it. And so rather than repeated reinvention, it led to the idea of, can we collaborate on common tools for that? So what we've queued up today is a survey, and each of these could fill an hour, but we won't, and I'll hold them to 6 minutes on what they've done, what they can plan to do, what they offer, what they need, leading up to a discussion of what we can do collectively rather than separately. And so This will take you through what I experienced at Santa Fe of both the progress of each of these teams, but also the relatively independent development of complete stacks of solutions, and then the opportunity to work together on that. So the goal for today is not simply to conclude today, but to launch this larger collaboration. This is very interactive. There won't be a separate Q&A time. Feel free to put questions in the chat, and at the end, we'll leave time for discussion at this fast pace. And so with that, I'm delighted to start with Jeff, just north of Yellowstone.
Thanks,
Okay,
Neil.
Jeff,
Can you hear me all right? Can you hear me all right? Great.
Yep.
That was the howl from a very special wolf called 907, and a reminder of why we do what we do. I'm going to give a quick update on a rugged battery-powered modular device we've been building for what's called the Cry Wolf Project, a long-term study of wild wolf communication, but it applies to other species. Decoding wild wolves is tough, right? They roam large territories, live in social groups and lone wanderers. They're notoriously hard to track and rough on their bodies and any monitoring tech. And I'd like to encourage people to listen to a biologist, Dr. Dan Staler, head of Yellowstone National Park's Wolf Project, home to some of the most studied wild wolves on the planet. He challenged us early on and with this quote: "Innovation means nothing in conservation if it can't survive the real world's problems and price tags." So with that, you know, in 3 years, we've recorded 200,000 hours of wolf life, including over 20 different call types, some brand new to science, and also the barfs, farts, and snores that never make it into nature documentaries. What you're seeing here is a map. Wolves, elk, and gunshots, for example, they're loud. You can think car horn loud, and we've recorded them from 8 kilometers away. We deploy battery-operated devices shown in the blue push pins here in a 6-kilometer grid across Yellowstone's northern range, which is roughly a 60-kilometer wide swath. And those colored polygons mark the territories of known breeding packs, each about 10 wolves, and the grid captures their vocal footprints, recording when they speak and when they're silent. You can go to the next slide, Neil. For the first time, we've been able to study wild wolf communication across entire landscapes, 24 by 7 by 365, with relatively low-cost ARUs or autonomous recording units like you're seeing here. What's interesting is ARUs like this one have many of the same electronic components as other monitoring devices. So we decided to take this approach of modularity and make acoustics modular and then combine it with, next slide. I'm not seeing the next slide. Neil, are you? Is everybody else?
Let's see, I am, right now I'm seeing no grass camera traps. Is that not updating?
There you go. There you go. So we're combining this acoustics modularity with the classic trail cam. And as you know, trail cams only have about a 20 to 30 meter detection range, and they're almost all initially triggered based on passive infrared sensors, even things like Google Nest. They're cheap and low power, but they're really bad at telling grass from a grizzly bear. So we've been focusing on the use of AI as smart triggering. You can go to the next slide. And as part of this modularity, we've come up with what we call the no grass camera trap, which filters false positives and reduces false negatives by using 2 different types of low power sensors. And this happens even before a photo is snapped or audio is recorded. And then we use TinyML to filter out unwanted objects, which might be like ravens at a bison carcass all day long. And then finally, we send a subset of true positives to the cloud, where we use, you know, really robust general purpose AI to identify everything from a wolf's fur color to a poacher's brute brand. And in essence, we created a compression algorithm for low power monitoring in remote landscapes. We're kind of trying to define a new category, kind of what Neil's talking about is this singular yet modular multi-sensory recording unit that can be used across species. We call ours GrizCam, which you're seeing right here, and its little sibling, the CubCam, It's battery operated. You attach modules to it, such as an 8 TB storage puck, which you can increase or decrease, 360-degree audio and image recording, environmental sensors, beacon logging that we hope to work with Patrick's CollarID later, and connected and unconnected modes. And its job is to capture the sound and motion that matters, right? They also need to be rugged. We're thinking about safety for wildlife and theft proof. We're experimenting with 3D printed materials encased in wire meshes that short and shock and dishabituate an animal that touches it. Next slide. Now, hardware without software is like the iPhone without the App Store, and modularity needs to extend all the way out to how the user manages the devices, including file naming conventions, which we all need to agree to. You're looking at our software portal there, which lets us manage millions of devices. Next. Now, beyond learning to speak wolfish, who really cares? Our mission, conservation mission, is advancing field science and sending private landowners and combating wildlife crime. One way we incent private landowners is by making our devices practical, like how do you tell if your water tank's full or there's a trespasser on your property, but also how to handle wildlife conflict. And you may have seen Wall Street Journal's recent article about the USDA using drones to play human sounds to deter wolves from livestock. I've watched it work, but what it fails to recognize is that wolves understand human voices and human-made sounds. It's not playlists of AC/DC or Scarlett Johansson. Wolves can also identify each other's rival wolf packs. And so what we did, next slide, is in the spirit of Interspecies Internet, we decided to see if we could detect wolves howling with triangulation and then send them a polite keep out message in their own language. In the photo on the right, GrizCam is emitting a known deterrence mechanism, a flashing light, and it's connected to a Bluetooth speaker and playing a large wolf pack chorus howl. So I wanted to call that out, especially in light of who we're talking to. And of course, the ethics are complicated here. AI can be used to kill wildlife as well as protect them. But what I look at this group is why is there no Anduril for wildlife? And how are we going to get there? They have, billions of dollars of funding. It's going to take a collaborative effort. But like Neil said, this modularity approach and thinking through each stage as a group is what we can do to get to scale. So with that, I'll kind of close on the last slide, Neil. You asked us what we're going to do next year. We're going to focus on acoustics, including a real-time gunshot detector and a sound localization module. We need help with better low-power, fast wake-up 4K video sensors, low-power, fast wake-up acoustics AI components, and we need amplification, or I'll just say it, we need money for what we're doing in the conservation space. So thank you, and I'll end it there.
Thanks, Jeff. That's a spot-on introduction to what today is all about. A tremendous innovation that you've been able to do just in the scope of your project that has broader implications. So thanks, Jeff, and we'll go on to Patrick.
Great. Thanks, Jeff. So my name is Patrick. I am a freshly minted PhD as of yesterday, and I've been working on the CollarID system, which you see here. It's a pretty small system with a microphone, temperature, humidity sensor, as well as looking at GPS data. Also has long-range radio. And then also we're looking at particulates, so like how dirty or dusty your air is. Next slide. And the reason I started working,
Jeff,
yep.
In the chat, Rajesh is asking about the wolves habituating. If you could answer that, go ahead, Patrick.
Yeah, and then so the reason I started working on this project is because when I have a sensing background, and a lot of us in my group in responsive environments also come from a sensing background. We build different sensors for not just for animals, but for humans and for other things as well. And what we found was that when you're looking at the world of animal collaring work, a lot of modern collars have GPS, which is becoming more and more common as these modules get smaller and smaller. Some of them have accelerometry, but that's just about it. And so when you talk to a lot of these ecologists and conservationists that use this data to infer something about the animal state and their behavior, they often make a lot of assumptions on the context that they're in. So for instance, are there other species of animals in the area? The only way you could really know that is unless you have humans on the ground seeing them or some cameras. You need to also, you would either then need to have all the animals have collars as well. And so it becomes a bit of a tricky problem. But what's interesting, though, is if you couple other types of sensing modalities like acoustics, and looking at, for instance, more higher resolution location data to see if like an animal is interacting with a latrine, then you're able to get more and more about the context. And honestly, that's kind of where we're at today with technology. We see these really small modular systems being built for people, but not as much of this is propagating down into the animal world. And there's a variety of reasons for that. And I talked about that a bit in my thesis. But as we build these systems, you also have to think about a lot on how they get abused. So people abuse wearables all the time, but in the animal case, it's harder to predict. And so we did a lot of FEA analysis just to kind of really figure out, will this thing survive with a lion bite or hyena bite? And hyenas are a bit more bitey than lions, although lions are stronger. And so we did some preliminary analysis on this, but we're currently doing some field work with hyenas and lions over the course of a year, a pilot study to see how well our simulation compares to the real world. Next slide. And then we've also been working with long range radio, specifically LoRaWAN. A lot of modern collars don't really transmit data, and if they do, it's via SATCOM, and that's fine for some things, but a lot of the satellite communication modules, they're larger, they're more expensive, you have to pay a service fee. LoRaWAN is for some locations it's more attractive because you're still able to get at least 10 kilometers of range, but also you set up one gateway that kind of serves your whole network, and it's pretty impressive on how small of an antenna you need to get reliable communication. So it's kind of interesting now that instead of just sending pings via VHF, or paying a pretty healthy dollar to for the satellite communication, we're able to set up these low-cost networks and get real-time data streams. Not audio, but real-time data in terms of where the animal is and some idea of their environment, or some higher order statistics of the acoustic environment that they're in. Next slide. And so with CollarID, we did a lot of environmental testing. As a PhD student, you have to get a bit creative. So if you want to play that sound. So this is what the inside of my dishwasher sounds like. We could pause it. But the dishwasher is a very hazardous environment, especially for electronics, and especially if you're using dishwasher detergent. And so we put a few CollarIDs through various cycles of the dishwasher, and not just in the sensor data from the temperature and humidity, you can see fluctuations depending on the cycle they're in, but you can also hear the sound of what it sounds like to be in a dishwasher, which is kind of interesting. Next slide. And then also over the last few months, we've been partnering with a regenerative farm in upstate New York, and we've been putting it on various cattle. For example, this is Myra. You can see her fashioning one of the CollarIDs. Next slide. And we've recorded a variety of audio snippets from her. So we could play a few. So we could play that one. So that's cows bawling. And they usually do that when they're stressed. So if they're separated from their young or if they're hungry. Another interesting one is the second one, where you can hear, oh, that's a cow walking. But the second one here, you could hear birds chirping, cows mooing, and also cow breathing. So these are the type of data that me as a scientist and a system engineer, I get really excited about, because we're able to collect this on the animal. And so you can imagine if we're putting these sensors onto lions and hyenas for the course of a year, that starts getting really interesting. And then also when we start exploring the idea of putting machine learning models on the CollarID system to detect certain sounds, certain anthropogenic activity, that kind of allows us to flex a few different dimensions. Next slide. And so alluding to where we are right now, we have 15 of the first prototype devices made and deployed on various animals. As of next month, we're deploying them on hyenas and lions in Botswana. In October, on domestic dogs in Kenya. We're also working with a few different collaborators here in the U.S. And I extended my time at MIT for at least the next 6 months to keep doing the development on CollarID as I raise more money to try to extend my postdoc a little further. And then the goal now is to make up to 100 of these devices to distribute across different communities of researchers and scientists and conservationists, to really get the ground get the momentum moving on this project, and then we're going to see how that propagates further. This is just like a brief summary of everything that I did. You could take a look at my thesis, which is, I think, now public. And there's a lot more information there.
Great. So Patrick, if you can answer in the chat a question from Arki about the cost. And Vin just posted, I think, 3 things that I've never seen together in a sentence, which is reindeer, LoRa, and interplanetary protocols.
Okay.
So then Kat wanted to join, but she's currently in a remote part of Guinea. And so I can't remotely do justice to the wonderful work she does, but I'll just give you a tour of the slides she shared. She's been focused on recognizing we don't want to be species-centric in understanding animal communication, which requires tremendous data sets to go beyond our inbuilt biases. And so rather than starting with what we think communication is and mapping it onto animals, starting with trying to understand what animals are doing. And so she's been working with chimp gesture and watching them and building up a library of what they're doing. And she discovered a huge range of gestures beyond what had been understood with this data-driven discovery. To do that, she instruments environments and then crucially focuses on what many studies considered noise, which was just the contextual information, both the variability and the contextual information. And from that then works up to build out semantics and then expression. And so her effort requires huge amounts of data. She has hundreds of terabytes. And then initially it was manually coded. And increasingly to keep up with the data requirement, they've been building tools to automate the data annotation. And so she has a publication in preparation on how the data feeds through automated annotation and then analysis building on that stack, showing that they can meet or beat human coders in the analysis and then be significantly more scalable. And so that's where she is, and that's what she's doing right now in a remote part of Guinea, deploying cameras, building large data sets from them, and then automating the analysis to figure out not what we think the communication is, but to parse it to interpret the communication. And again, this is a publication in prep that's going to describe the pipeline she's had to do for that. And so a lot of her effort has gone into not simply the field work, but how do you build this pipeline to gather and analyze huge amounts of data to recover gesture and syntax and language. Okay, so that's a quick intro to Kat's work, and then we'll go on to Joris.
Hey everybody. It's interesting that Kat's work comes before mine because I think we are working on very similar projects, although the species is different, but the project, the kind of methodology is very similar. I'm an architect by training. I happen to have a conservation background by proxy through my parents and through where I grew up in Namibia. And because of that, I'm really interested in whether or not there's a difference between the behavior we observe for wildlife in the wild versus the behavior of wildlife in what we like human modulated environments, but specifically places where communities are developing in conservation areas. And in Southern Africa, we're seeing a lot of that. You can go to the next slide, Neil.
And by the way, Joris, where are you right now?
I'm currently in the Kruger National Park in South Africa. I'm doing some field work, and I'll kind of touch on that at the end.
Okay.
All right, so to do what I've been doing, and as I said, this is very similar to what Kat's doing, and I would love to have a bigger conversation with her and whoever else is kind of interested in this. We developed a tool called PackySet, and PackySet is it's a fine-tuned pose estimation tool for elephants specifically. The super quadruped model that this was based on didn't take into account the trunk, the tusks, the size of the ears. And I'm really interested in the kind of micro scale behaviors of an elephant between, say, 2 buildings. And so PackySet facilitates that for us. And this data set was built actually primarily on synthetic data from Unity. And it's proved to be really, really successful. And what that's doing is it's kind of reducing the need to collect data in the field.
So, Patrick, just to unpack that slightly. Unity is a video game engine. Unpack how you used it.
So Unity is a video game engine, and what we're doing is I basically load in a model of an elephant that's animated. I generate a video of that elephant walking through space with a randomized kind of background. That in hindsight, I probably could have used a bright pink background. I don't think it would have mattered. But I then take that and then label the images from those kind of synthetic videos to then later use for the pose estimation tool. You can go to the next slide then, Neil. All right, so then given the kind of data that we've been collecting, and I've had a series of cameras up in the Kruger National Park the pilot project was last year, September. With that data, I developed a thing called Anaviz, which is basically a data viz analytics platform for behavioral scientists. So specifically in these kind of new environments where we don't have any information about the behavioral, but like about behaviors of elephants around buildings. So this kind of thinks about how we might reveal potential new behaviors in new environments, places where the animals might be pausing and kind of exhibiting new behaviors, clustering their kind of the kind of positional data. There's a couple of little tricks in here, and then just ways for people to kind of make notes and then tag specific time frames. Okay, you can go to the next slide there, Neil. This is just part of that Anaviz system. The top, we're just looking at how over a specific time frame. So the first slide you looked at kind of a static position of an elephant. The second slide is a kind of time-based slide, and this is a term that I'm calling etholometry, which is basically the metrics of behavior over time of a species. And then the bottom up, we're just testing on some of the real data that we've collected. And I'll post the link in the chat if anybody wants to kind of look at the website and see and kind of play with the tool. I'd love to get feedback on kind of how the tool's working and how we interact with it, because I think that's very valuable, specifically because I would say, I have to admit, I'm not a behavioral ecologist. And so partnerships with ecologists and behavioral scientists is critical. And as a kind of a tool builder, that's quite important. This is just an example of what happens. Like this was the space where I was collecting the elephant data. It was the cameras. It's very simple over-the-counter purchase camera traps or trail cameras. I'm not using any kind of there's nothing customized for the work. And I think that's quite important for a lot of conservation projects, because tools are really expensive and inaccessible. And specifically in places like Southern Africa, it's really hard to get hold of like new cutting edge tech. And so I just use whatever I can get locally. And so this has been kind of how I collected this data. And then I have to think kind of carefully about what the data looks like later. Here, I'm just simulating kind of like once I've got the elephant collected, like what the information looks like. You can go to the next slide. So, and this is perhaps the most kind of important thing that we're doing at the moment, and this is what probably works very closely with Kat's work, is that we're trying to work out a way to visualize or develop methods to make behavioral sequences interpretable by machine learning models. I'm finding that like pose estimation data as it stands as an image doesn't really kind of translate well enough into kind of predicting what a behavior might be. And so we're thinking about ways that like a Fourier transformation, like loosely, Neil, I don't want to speak out of turn here about Fourier transformations, but just like like what are other ways we can visualize what a behavior looks like over time or given a specific time frame? Okay, and then the last slide, please. And so this is what I'm doing right now. I'm basically building a one-to-one scale lab in the Kruger National Park. We've got 28 cameras, 5 buildings on wheels, and about 30,000 elephants. And the project basically is a way to test the software that we've developed to understand how elephants interact with the built environment. And so this is kind of I would say that this is the very last most important part of the thesis work that I'm doing as a PhD. And I'm currently in the midst of building those buildings. So I've got about a week left to build about 5 of them.
Okay, great. Thanks for calling in from Kruger. And Yuris, in the chat, if you could answer Arki, who's asking about individual species identification, whether that's possible. So Leo.
Hi, yeah, my name is Leo Trottier. I'm founder and CEO of Fluent Pet. Fluent Pet comprises hundreds of thousands of people, customers of ours, who are interested in teaching their dogs or cats to communicate in language-like ways. Also the founder of the massive Interspecies Communication Observatory, which recently received funding from the Canadian Institute for Advanced Research. This is an organization that seeks to connect data sources to researchers, independent academic researchers around the world in order to better understand the potential for interspecies communication. So that's what we've done. Our plans are to turn this idea, currently this massive interspecies communication observatory, into a reality. This is a long project and it's going to continue for some time. So we're building out infrastructure for that. But also we want to we want to make it possible for Fluent Pet to share this data as well. So just trying to answer the Neil's questions here. What we can offer, we have a historical set of, so let me just kind of move through some of these slides. So this is the community that we've pulled together. It's a very creative group of individuals who are creating these, who have these little sound buttons. These sound buttons produce words when they're touched by a dog or a human. And we see a lot of really great evidence that dogs and cats are using them in extremely interesting and intelligible and useful ways. Next slide. That we have an automated system that, well, we enable people to capture and log exactly everything that their dogs or cats are doing in an app. And we also have an automated system for capturing that as well. Next slide. So this allows us to do some analysis. We can see like which buttons get pressed the most. Not surprisingly, like dogs really like to ask to go outside and to play. One interesting distinction we found is that humans will say love you more often than the dogs will. So there's asymmetries in terms of the who is saying what. Next slide. And, you know, we can, of course, plot all of this. Next slide. This has led to the production of at least 2 peer-reviewed data-oriented papers, one in Scientific Reports, the other in PLOS One. Next slide. Yeah, and some findings that the data are not just like random button mashing, but in fact are look like the kinds of things you would see from interesting, meaningful communication. Next slides. Oh, right. So what can we offer here? So we have kind of done some informal stuff within the company. We have people who have compiled a glossary, for want of a better word. This is all, of course, very anecdotal, where people will say that different combinations of button presses refer to other more complex concepts. We also have this database that we compiled of over 500 instances of communication that our users have reported, and sometimes they've filmed. So this is just a Notion database that I can provide. I'll provide a link to after this little presentation. Next slide. And one of the things that we have added to this is, here we go, a partnership with a camera company. So this has enabled people to integrate the cameras in their homes with the Fluent Pet app, which is fun for the people, but it also, of course, enables a lot more useful analysis as well, especially now that sophisticated AI tools will allow for automatic behavior categorization and all this, the things that, of course, we're seeing from AI-based video analysis. Next slide. And so the thing that we actually put this together a little while ago, but we think it would be really valuable to have a data sharing protocol. So this is a common event stream that is super extensible and that everyone could put any animal communication, human, non-human alike, into a common, very simple, very lightweight, minimal JSON format. So we've created a super early draft of this data sharing protocol. Would love to get feedback on this protocol. Would love to see people, love to see it get to a point where people are excited about putting research data, and of course, startups like Fluent Pet and others, putting whatever data that they feel like they can share about like animal communication. So turning that into a useful format would, I think, be super valuable. It's something that we've been talking about with the Interspecies Internet team for a while. And if that could be an outcome of this meeting, I think that would be a great success. So I think is that my last slide?
Leo, yeah, 2 questions. One, can you talk a bit about your work towards a common data platform?
Yeah, so this is, currently it's just a JSON schema, which is located at that link. It is meant to be extremely high level. It is meant to be extremely flexible. We are looking
sorry,
for...
Leo, that's data interchange. What about where does the data live?
Oh, right. Yes, sorry. With the Massive Interspecies Communication Observatory, the notion is is that it would be a largely three-party collaboration. So on one of the parties would be like data sources, both researchers, but also like startups like Fluent Pet who have data that they're willing to share. We've been sharing this kind of in a bilateral way with Federico Rossano's lab. We would like to be able to share this more widely because we think the data is really interesting. And I think there are other entities that probably have the same inclination. The second entity in this kind of the 3 groups are, of course, the researchers. So the researchers gain access to this data and they can analyze it however they want. And then the third entity is Interspecies Internet as like a kind of overseeing organization. The place where the data would live would be at an academic institution and so that is a kind of neutral, as it were, and trusted third party that where researchers and willing participants that are on the commercial side would trust to store and handle their data. So that would then be subject to all the standard IACUC, IRB data safe and other kind of data privacy protocols. And we have tentative agreements in place with UC San Diego. The grant that was just awarded was awarded to Yale. So there's potential that Yale would be involved as well. That's where the data would likely live. So I think we've also had communications with the Internet Archive. So to the extent that it could live there, that would be another great place for the data to live as well.
How do people connect if they have data looking for a home?
Yes, please email me at just leo@fluent.pet. I just put my email address here. And it's still early days, but we are very excited about making all of this useful to researchers around the world.
Great. And Vin asks if dogs have a way to say stupid human.
Many ways. There's actually a famous video of me being told to stop doing annoying things by a small dog that I was trying to adjust the lighting in this Airbnb that I was with like multiple other dogs in, and the dog did not like the lighting adjustments I was making and let me know.
Okay.
I'll share a link to that in a few minutes.
Okay, finally, I'm delighted to end with Eric Pan, who's my favorite route into the Shenzhen innovation ecosystem. Eric.
Thanks, Neil. Hi, everyone. This is Eric.
And thank you, Eric, for staying up past midnight in Shenzhen.
Yeah, no problem. It's a weekend for me. That's a perfect project for the weekend. So I'm big fans of With the Wild. So I'm big fans of all your work. But we have done quite some of experiments. We support a lot of projects for the wild. I think in this conversation, we are from very different perspective. We are more like a blacksmith to whatever you have been doing. So City Studio have been doing open source hardware from 2008, and we are more evolving into devices. And whenever we build devices or sensors in like more advanced form factors, and we have to change ourselves to put them into the wild. How can we fetch more data from the age, the frontier of the civilizations? How can we send the data back? So that's where we build a lot of outdoor environmental sensors, trackers. And I think that contributes to a big topic is how can we collect more data from everything to AI. And also we do a lot of AI hardware from a few years ago now. The topic also evolves into how can we squeeze AI into different form factor and press into things. And next slide, please. So we have been cutting AI into small form factors like a shell, and people not only see its like conveniences, but also it becoming very pervasive. People can now put in the shell into all kinds of places, and the people from all over the world can just repurpose the AI for their usages. I think it's becoming a lot more interesting to rethink. Oh, thanks, Neil. Well, rethink that you don't need a server. You can now very easily adopt in. You have all existing things and the animals, but now can just press a button to put the things inside, and that gets a lot of attentions. And we are very excited to see people has the confidence of using AI for themselves. Next page, please. And along this small AI, we also build all the form factors, all kinds of devices into for the edge, because we believe there are a lot of places you don't have cloud, especially in the wild. How do you process the data? How do you have more AI means to compress the data? With tiny machine learning, you're actually distilling the bigger amount of data through cameras, through sound, but distill them for the key messages. And our customers has been trying to use our trackers or variety of devices for their animals. So no matter how many form factors we build, the AI hardware is becoming diversified very quickly, and we have a hard time catch up with all the kinds of needs. But I think from this conversation, we are very interested to see the hope of fine-tune them and towards more standardized, modular, open devices for interspecies. Next page, please. And beyond AI, I think a few other speakers have been talking about LoRa, which is becoming very critical in our mind to get the data from afar. And besides LoRaWAN, now Metastatic is really picking up in varieties of developing countries because people can rebuild their communication network either regardless of the telcos. In Ireland, you can build your own like network, and you can work with each other to form a larger network. That has been quite impactful. And some of the animals can be your base station to relay the information as well. Next page, please. But on top of all the AI and LoRa, I think it's just a start. We have building many devices. We have been helping many people build more devices, but they are just a start. Whatever we built and we shared today, they are like open source. You can see them as reference device. We have done some of the heavy lifting works, like how do you make it durable? How do you do it, make it like no power consumption, like one battery lasting for 10 years? How do you transmit it from afar? But we lack of real scenarios, because in Shenzhen, we have a lot of technologies. We have a lot of factories, hardwares, but we don't have the wild. It's very hard for us to build anything and to validate. Like I see that Jeff or Patrick has been showing how do you validate the animal's bite. we cannot predict them. We have to build form a new way that build a device that can be decentralizedly synchronized, and you can verify them in Yellowstone National Park. You can test the because there's so many things beyond our imaginations by regular devices used by human beings. This kind of devices have to survive in the wild that beyond any quality standards. So I think it's very important. Starting from this conversation, we need your inputs. We need to understand how can we help. How can CStudio help you to build more wide-friendly interspecies practical devices? And it's very fast for us to build something on top of these reference designs from AI or for LoRa. So building the electronics might take just a few weeks. Building the injection molding is just 1.5 months. But how do we validate them? How do we prove they can be working in the wild? I think through this collaboration, we can build a very interesting, important network to push it forward. And also, I think we like to propose to form a way, not just stay at the research paper, but make them open device that other people can use. And they could be modular, and we form together, and they can be scaled, and we can contribute all the profit back to some fund to support more makers who want to bring all the AI and IoT technologies for the real interspecies conversations happening. I see so many exciting ideas, explorations coming from the conversation, but how can we enable more people, like, for example, to get the dogs talking to you? So that's for the parts I want to share. Thanks.
Okay, so let me pick up on Vince's question. So again, Eric Pan and Seed aren't a structural required part of this project, but the reason I'm delighted to have them involved is they're very strongly focused on open designs with returns to the community, leveraging all the innovation and skills of the Shenzhen ecosystem. And we've done lots of really agile projects with them. So in the chat, Vin is asking how to get in touch with Eric and work with him. The first is easy. Eric can put his email in the chat. The second is a bigger question, which is Eric and Seed can't tackle separate projects for each team. So in today's session, I queued up these impressive groups that within their groups, they've built up all this expertise to build full stack solutions that are very impressive. It's a very high barrier to entry for anybody else to redo what each of these teams have done. And it should be clear there's all sorts of synergies across these projects. So I'd like to thank everybody for staying for the 6 minutes a topic. We have 10 minutes left. And in those 10 minutes, here are my questions. We want open designs. Open doesn't mean free. We need supply chains to source them. We'd like to see returns from them to help the community. As Eric notes, as many people have noted, no one group or person knows how to do this. We need to collaborate on it. Pretty clearly, this needs to be modular rather than bespoke solutions you can compose. We need to recognize multi-modal interfaces. There's a wide range of types of interfaces. You've seen some very impressive programming that's a very high bar. We need low, no-code programming to make it more accessible. And all of this needs to be supported by scalable data platforms. And so this leads up to why we scheduled today's session. 10 minutes to discuss how do we kick off doing this. Feel free to put comments in the chat, raise your hand, thoughts on how to, hopefully now you have a sense of the sense I got in Santa Fe that there's a need and an opportunity for something bigger across the community. What are your thoughts?
So Vince got his hand up. one thing that it seems apparent would be to, for this particular presentation to be exposed broadly to the community that's studying animal communication so that they're aware of some of the things that have happened and the possibilities and available capacities. I think the more broadly we can articulate these capabilities, the more likely it is that some of our colleagues will find them useful to help populate their own facilities for data collection. The second thing is the data itself and the idea of finding ways of assembling large quantities of diverse data and making it easily accessible. And I mean that not only by getting the bits, but also getting an understanding of what it is. Leo's point about JSON structure, for example, would be an example of something that would probably make parsing of the data more understandable. So how do we get more exposure to what you've just shown us for the last 50 minutes?
Well, as we're talking, let me start writing things down. So Eric, I think, is already signed up to help with design for manufacturing, commercialization, production. Is that fair, Eric?
Yeah, we are very happy to contribute our engineer hours and all the profit making from these projects.
Okay, that's a wonderful thing. And then Leo, you're already effectively signed up, is it fair to say, for work on the, remind me of the wording, the observatory?
Yeah, so we have a massive interspecies communication observatory that's it's an established nonprofit that was founded technically the entity was created a few months ago. There are a few tentative and formal agreements that are in place. And I think this would be a place where a lot of these, like the protocol can live, resources can live. We have a website, actually, I'll just share that right here, called micoproject.org. I just sent that link. So you can see kind of the people that have gotten involved. We would love to have more people involved. We'd love to add more people to our partner list and a list of friends of the project. So yeah, would definitely please check out micoproject.org. I should also note that there is no accepted event stream format schema, definitely no RFC or IETF such, like standard for behavior data from animals. It seems like if we got one, it would not only make it a lot easier to analyze data, I think it would also smooth people's, any entity like ours ability to, and incentive to just like share data to the extent that we want to. Obviously, there's a lot of reasons why people might not want to share data, but sometimes there is interests are aligned in a different direction. And to the extent that companies like PetCube or Fluent Pet might want to share some amount of behavior data and communication data from, of course, properly consenting research participants, like this should make it a lot easier and incentivize them to do so.
This is working. Let me note where we are. Eric's signing up for manufacturing. Leo's building data platform. The Interspecies IO organization just sort of naturally, one of the things it can do is assist with project management. Another is to assist with bundling this whole community to get it before funders. I think one thing that's missing is curation, is somebody trying to help survey the map of what are all the devices and what are all the applications. So hands up, Rajesh.
I'm not signing up for the curation, or maybe I am, but at least of some interest.
Go ahead.
I'm wondering if it's worth picking one sort of place of intervention, like a park or somewhere else where multiple species could be simultaneously studied. The technologies, the protocols, the researchers could all interact. Like maybe that's a model kind of project for doing this in like creating you could say animal communications ecosystem that parallels the natural one.
Okay, noted. Vin?
I put something in the chat. I just wanted to draw attention to schema.org, which is a place where data formatting and semantics are proposed. Standards are they're informal, but they're potential places where we could engage in developing standardized formats so the data exchange is more feasible.
Good. 3 minutes left. So who else wants to contribute to this collaboration or needs help from the collaboration?
Well, we definitely need help over on our end. So
What kind of
I've
help?
already mentioned that, but feedback on the schema that we've developed, we want to keep it, of course, very lightweight. That was the point that Vint made some time ago. But if you are interested in please let us know. We want this to be a thing that gets adopted very widely.
Great. Okay, Treasurer.
Yeah, Leo, I think we need to follow up on that because we're trying to do a schema in the natural world, right? Which has got a little more elements. But the notion of an event structure is really important that a lot of people don't talk about. So I will make a note of that too.
Okay, Treasurer.
Yes, I mentioned in the chat that I had produced a low-cost video production unit for Fluent Pet or some kind of a similar application. I also have a use of a few different underwater ROVs from my time when I worked for So Far Ocean, and I would be willing to loan those out, and I would love to get involved with helping produce hardware for these events and for advancing the cause for interspecies communication. I mean, I'm here in San Francisco, so we're no Shenzhen, but we do have a lot of access to technology off the shelf and a lot of stuff that's being repurposed from different industries. And with regard to the gentleman's comment about being the next Anduril, I think that's a fantastic goal, is to repurpose a lot of this defense stuff into useful things that can help us advance interspecies communication.
That's great. Thank you for that, Treasurer. Rajesh, if you're willing, could I ask you on an interim transitional basis to take on the curation function? And is that what I see that as being is the chat is full of, I have technology to offer, or I have species that need this, and it's helping build plumbing for how we connect all of them. Down to questions as simple as like, is there a chat? But part of your job could be, and we'd work with you to find your successor, but initially taking on the curation function. Is that okay?
Sure.
Thank you. Eurus?
Yeah, I think one thing that would be quite interesting to think about, especially maybe just on what the work coming out of Seed is doing. But I think that there's a massive need for thinking about like where the technology gets developed and how it's deployed in those places and how to make it accessible. Because what we're finding in Southern Africa is that we get to see all these cool tools, but we can't get hold of them. Or we can, but then importing them is really challenging, or it's really expensive, so there's a lot of kind of barriers to access. And so if there was a way that we could think through how to kind of get over some of those barriers to access through the interspecies.io kind of work, it would be super, super useful. And there's so many projects going on that would benefit from this kind of work. So yeah, if we can maybe just think about that in some way, that'd be great.
Okay, Jinger, I see you're on. Can you do a 1 minute, a 30-second introduction?
Yes. Hi, Neil. Hi, everyone. Yeah, I'm Ginger from Hackster.io. We are a community of hardware engineers, and we're also actually hosting a contest where Jeff actually is a judge, and we're long-term partner with Eric and Seed Studio on doing a lot of different engineering engagement contests, but we are 2.4 million developer hardware engineers community online. And if you are looking for technical expertise, please contact me. I'd love to support. And also the developer we have is around the world. So we have amazing what we call Hackster Pros, also in all over the world, including in like South Africa, in Africa, Southeast Asia, all over the world. So I'm pretty sure we can match up some of the technical talent here to help with this initiative.
Great, thanks, Junior. So we're up to
Thank
the slightly over the hour. Carolina notes there's an interspecies Slack. So absolutely, yeah, I'll write up a quick summary of this. Absolutely, starting a channel in the interspecies Slack is a good starting point. And again, I think this will work. We have a really interesting stack of Eric volunteering to do engineering work, design for development, transition to production, Leo building a data platform, Rajesh agreeing on an interim basis to take over community curation, Interspecies helping with project management. This is the infrastructure to really build a community project to together take these great examples we saw today and deploy it more widely and make it more accessible. And so with that, that was the goal of today's session. There's some more hands, some more questions, but we can pause here to stop the recording. And for people who have to leave, which includes me, we'll say goodbye, but this doesn't end now. This really just begins. So thank you for all the great work preparing. Thank you for the volunteering and the general arm twisting. And I'm really eager to see what we can accomplish. Thank you all.
Well done, Neil. Have a
Bye.
great weekend.
Bye-bye.
Thank you, everyone, for joining us for this very productive discussion. If you'd like to learn more about anyone's work, I'm just going to share some links in the chat. And thanks again, as always, to the interspecies community, Interspecies Internet community, for your engagement and interest in the interspecies conversations events. If you'd like to learn more about our organization or stay up to date with our lecture schedule and other projects and activities, donate to help fund our programming, or connect with a community of researchers and enthusiasts, then please follow us on social media, visit our YouTube channel, as Neil mentioned, join our Slack, and subscribe to our newsletter. Carolina will share some links with you in the chat shortly. So yeah, on behalf of the Interspecies Internet, the trustees, and the community, thank you for joining us today, and we hope to see everyone again next month. Thank you.